So we are working on the Lewis structure into VESPR structure worksheet that was assigned on May 11th, it sounds like. Okay, so first thing we have to do before we can figure out VESPR is to determine what the Lewis structure is. So before we can do that, we need to figure out what carbon tetrafluoride is. So what is carbon tetrafluoride?
CF4.
CF4. All right. So how many electrons does carbon bring to this mix? Who's playing guitar?
Oh, somebody's mowing.
Okay. How many electrons does carbon bring?
4.
Yeah, 4.
4. Okay. How many does fluorine bring?
28.
7 times 4 is 28. You skipped ahead a little bit.
Oh, sorry.
No worries. All right. So all together, how many do we have?
32.
32 electrons. Does everyone know where I got that number from, or where Christian got that number from?
Yep.
Just add the 28 plus the 4. So that's how many we have total in the entire compound. All right. So what's going to go in the middle? Is the carbon going to go in the middle, or the fluorine going to go in the middle? Carbon.
Yeah, carbon.
Okay, there's a couple of different ways you can figure that out. One way is it's the least electronegative. That's like the official way, is whichever one's the least electronegative. So carbon's the furthest away from fluorine. The other ways that you can figure it out is there's only one carbon, but there's 4 fluorines, which means carbon will be in the middle and fluorine will be on the outside. And then finally, the third way you can figure that out is look at the individual electron configuration. Carbon has 4 dots around it. It has 4 spots to make a bond. Fluorine has 7. It only has one single electron there that can actually make a bond. So because of that, because carbon has 4 and fluorine has 1, carbon's going to go in the middle because it has more opportunities. You follow that? Anybody confused about what I just said? Because I kind of said it fast.
We're good.
All right, so I have carbon with the 4 fluorines. What do I do with the C and the F? What do I draw between them?
A line.
A line to represent the bonds, right?
Yeah.
So how many electrons do I have used up there with just the lines?
8.
8. So 8 electrons are being used. All right, so that means how many more do I have left to use?
24.
24, because 32 minus 8. So 1, 2, 3, 4, 5, 6, 12, 18, 24. Okay, so there's my Lewis dot structure. Did everybody get to that point? Or did you even attempt it yet?
Yeah.
Okay, so how many bonds do we have coming off of carbon?
4.
4. How many lone pairs do we have on carbon? Any?
I don't know.
Is there any lone pairs around them? Or are they all on fluorine?
They're on fluorine.
They're all on fluorine. So if I look at this chart that I gave you, I'm looking for bonding in lone pairs. Okay, I have 4 bonding and no lone pairs.
So it's tetrahedral.
So it's tetrahedral. So all I'm doing with this is matching up what I drew for the Lewis structure to what this chart is telling me. We did this at the probably around Christmas break last year. Okay, so you had to line up this, and then match it up to what it's going to see. So this is the shape it's going to look like. All right, so let's try another one. Are we okay with that first one?
Yeah.
Yeah? Okay. I don't know if that was Sarita or Sabrina. Is the other one okay? The other girl?
Yeah.
Yeah,
Good.
okay. All right, so let's take a look at BF3. If we look at our periodic table, that's the first thing we need to do is figure out how many electrons each of them bring in. So how many electrons does boron bring in?
3.
3. How about fluorine?
7.
We have 7 times 3,
21.
because that's how many, because there's 3 of them. You good?
Yeah.
Okay, how many do we have total?
20. Is it 24?
24 is correct. All right, so which is the least electronegative?
Boron.
Yeah.
The least.
Or is it fluorine?
It's going to be boron because it's the furthest away from fluorine. Remember, fluorine's the most electronegative you can get, so boron would be the other one. All right, so that means I have 3 fluorines to surround it. What do I do now?
Draw the line.
Draw the lines. All right, so how many electrons do I have used up now?
6.
6. So 24 minus 6 is what?
18.
18. So I'm going to go around and do lone pairs. Remember, so on the outside in, does hydrogen ever get lone pairs?
No.
No. So that's 6, 12, 18.
Hydrogen.
No, I'm just saying in general. Hydrogen's not in the structure, but in general, hydrogen will never be in the middle and it'll never have a lone pair.
Okay.
As we're filling them, I like to remind you of random stuff like that. Okay, so this boron here, is that an octet? No. Is it ever going to be an octet? Huh? It would have to have 80 electrons around it. Boron, because of the 3 lines, only has 6, but that's okay because boron will typically have 6.
Okay.
If it has more than 6, this fluorine would have to donate the electrons, which would screw up the charges.
So you don't have to do a double bond?
No, there would not be a double bond here. I'm just trying to reiterate why we wouldn't have a bond there, because we try to eliminate the charges as much as possible. Okay, so I'm going to erase this so we don't confuse people.
Okay.
B, F, F. Right, so this is what we started with. Okay, so let's go to our chart again. First off, how many bonds do I have here around boron? 3 bonds.
6, or is it 3?
It's 3 bonds, 6 electrons, but 3 bonds.
Okay.
Boron itself have any lone pairs?
No.
No, so we have 3 and 0. So which one has 3 and 0?
Terminal planar.
Terminal planar. That's right. So I just match it up. That's all I did. And like I said, that chart that I've been flipping back and forth is I deliberately used the same chart that I gave you. Just to give you a heads up, when you get to college, I've heard people say trigonal, which to me sounds better, but I've also heard people say trigonal. To me sounds really weird.
Yeah.
I don't want you to be confused when you get there. It's all about, scientists like to pronounce things in weird ways. Kind of an odd bunch.
Just a little bit.
What did you say?
Just a little bit.
Just a little bit. Just think you guys will be one of us soon. All right. Are you ready to move on? Are we kind of grasping this idea?
Yeah.
Okay. Sabrina, how about you?
Yeah. Oh, yeah. Oh, yeah.
All right. I'm sorry. Your voices sound very similar when I can't see your faces. All right. So nitrogen. How many?
5.
5. Fluorine.
7.
7.
You have 3 of them, so it's going to be times 3.
21.
So 5 plus 21 is
26.
a difficult math question. What's 5 plus 21?
26.
Thank you. All right, so what goes in the middle, the nitrogen or the fluorine?
The nitrogen.
The nitrogen will be in the middle because that's the most unpaired, plus it's the least electronegative. That means fluorine's going to be around it. We're going to draw bonds. All right, so once I draw the bonds, how many bonds are being used right now?
6.
6.
3. Sorry, I don't know.
There's 3 bonds. Each bond is 2 electrons.
Okay.
So there's 6 electrons. I have 20 left to cope with. What do I do first?
You have to draw another line.
We're not going to do more lines. What do we draw instead?
Fill up the fluorine.
The dots around the fluorine. All right, so how many electrons do I draw around the fluorine at this point?
18.
18. I have 2 left I have to deal with. Put any more on fluorine?
Mm-mm.
No, you draw to
No,
draw
why
the
not?
nitrogen.
I put it on the nitrogen. Why won't I put it on the fluorine?
Octet is full.
The octet is full. Well, that sounded like not the word I wanted to say. The octet is full. So we have 2, 4, 6, and then this bond here is 8. So I have 8 electrons around fluorine, so I can't add any more to it. So instead I put it on the central atom. And now nitrogen actually has a full octet there. All right, so how many bonds do I have?
3.
3 bonds. Do I have any lone pairs?
Yeah.
I have 1 set of lone pairs. So look under the paper. We're looking for 3 bonds and 1 lone pair.
Wait, which one was the lone pair?
Right here is the lone pair on nitrogen. Okay, so we have 1 set.
Okay.
All right, so I'm looking at this. Which one has 3 bonds and 1 lone pair?
Trigonal pyramidal.
Trigonal pyramidal is correct. I go over here, and I'm going to write out trigonal pyramidal.
That's so the lone pair it's when the one in the middle has extra.
Yeah, we're looking specifically at that center atom. All right. I want you guys to try one on your own. So I'm going to pause the video, and I'm going to let you guys work before we get started. Okay? All right, so first thing we're going to need to do is figure out how many electrons each of them bring. Now, you guys had a chance to look at this ahead of time. So tell me about the hydrogens. How many electrons does a hydrogen bring? 2. Because 1 times 2 is 2. How about the carbon?
4.
Sulfur?
6.
All right, so we have 2 plus 4 plus 6 equals 12. All right. So which of these are going to go in the middle? Which one's the least electronegative with the exception of hydrogen?
Carbon.
Carbon goes in the middle. That means everything else goes around it. Sulfur, hydrogen, hydrogen. I went ahead and drew in bonds.
That's what I did wrong.
You forgot about the hydrogens?
I forgot. Yeah.
I kind of assumed as much. Okay. All right, so how many electrons do I have there so far?
6.
6. So I have 6 more left. Can I put anything on hydrogen?
No.
No. Can I put it on sulfur?
Yeah.
Yeah.
So 1, 2, 3, 4, 5, 6. Okay. Check your octet. Is carbon a full octet?
No.
Can it get to be a full octet?
Yes.
Yeah, so what we're going to end up doing is these 2 electrons here from sulfur, we're going to make what's called a coordinate covalent bond, and sulfur is going to have to share his electrons. All right, so that means that it ends up looking like a double bond here. And that's where double bonds come from.
Well, how am I supposed to know when I'm supposed to share it?
What?
How am I supposed to know when I'm supposed to share it? Because
You check for the octet.
Well, how
Yeah,
do you
but-
tell which elements will you do? Like, so boron, we didn't do it, but why? What
Yeah, I
changes? How do you
know.
tell?
That's what I'm saying.
Boron is an exception to the rule typically. That's why I made a deal about pointing that out. It typically will only have 6. It won't really get to 8. And that's really what it comes down to, is boron being an exception to the rule.
Is that like the only exception, or are there others?
There will be others. I think of a good way here. Hold on, I'm going to pause it a second. So boron's really small. And so because it's so small, it doesn't mind if it doesn't have enough electrons. Kind of like hydrogen doesn't mind if it doesn't have an octet, because it would be too cumbersome. Some of the bigger elements can actually have more than an octet, because it has the room for the electrons to move around. What you need to do is, as you're doing these, you need to figure out how to best satisfy the octet while not messing with the formal charges as much as possible. So, on our last video, we talked about formal charges. Okay? If I look at, I'm going to actually add a page here real fast. All right, so if I look at our structure, hydrogen, and then sulfur's over here with 6 electrons, and then hydrogen, carbon, hydrogen, and this one has a double bond. Okay, those are our 2 structures we're debating with, right? Can you see mine or not?
I can't see anything.
Did it get stuck? All right, when I added the extra page in there, it got all mixed up. Okay, so these are the 2 structures we're trying to decide between, right?
Yeah.
Carbon brought in 4 electrons, while sulfur brought in 6. If I break each one of these bonds in half, let me change the color. If I break each one of these bonds in half and say 1 electron's going to carbon, 1 electron's going to hydrogen, and I do that for every single one, how many electrons does carbon have around it right now?
How many? What?
1.5?
Electrons are specifically for carbon.
I'm confused.
All right.
Isn't it technically 1 because you divide the bond?
Okay. Let me try this again, so see if I can do it without confusing you. Okay. How many electrons are total around carbon right now? I'm going to try to explain this a different way. If I look at carbon, how many electrons are around it right now?
6.
6 electrons. If in each bond, 1 electron goes to 2 different ways, like 1 electron goes to carbon, 1 electron goes to sulfur. Okay, I can break all these bonds in half. So how many electrons does carbon have now? If I broke all the bonds in half?
3.
3. Okay? So if it has 3, but it brought in 4 electrons, does it actually have more or less electrons than what it brought in? I'm talking about formal charges right now. It has less. Right? So this is actually a +1 because it's deficient 1 electron. It has 1 less electron than what it brought in. Did you follow that? A little bit?
Yeah.
Yeah. Okay. How many? Look at sulfur now. Look at this sulfur here. How many electrons does it have for lone pairs around it?
6.
Six,
4.
two,
Oh, wait.
four,
Never mind.
6. And then we have this bond here. If we take half of that bond, how many more does it have? This electron comes over to sulfur.
7.
We have 7 total. We're adding 1 more electron to it. You follow that? Difficult concept. So if you don't follow it, I understand that you're confused. Why you're confused. So does sulfur have more electrons than it brought in or less electrons than it brought in? Brought in 6, it now has 7.
Oh,
so more.
It brought in an electron. Okay, I mean, it has an extra electron, so it has a minus charge. So carbon's positive, sulfur's minus. You see how I got that? Kind of? Okay. Those are called formal charges. That's what you were supposed to learn a week or 2 ago. Okay? We were doing all of this. Alright. When we're doing Lewis structures, we're trying to minimize that formal charge. We're trying to make it as close to 0 as possible. So sometimes that requires us to move those electrons around a little bit. And that's what I was talking about, like some of them are satisfied, some of them aren't, so on and so forth. Boron only brings in 3 electrons. So if it has 3 bonds, it brought in 3, it has 3, it's good. So let's look at carbon on this other side. Let's look at this carbon here now, on the blue. How many lines are going to carbon?
4.
So it has 4 lines. That means it has 4 electrons if I cut each one of those bonds in half. You follow that?
Uh-huh.
Is there anybody?
Yeah, but why are we doing this?
I'm showing you why. You asked me, how do I know it's going to be a double bond? That's what I'm showing you, is why you know it's going to be a double bond.
Oh, I get it.
Okay.
I don't get it.
Well, let me finish. Okay, carbon has 4 electrons that are bonded to it right now, right? That are around it with the bonds. How many did carbon bring in? If I looked at the periodic table and we did the Lewis structures from the very beginning, Sarita, how many electrons did it bring in?
8.
It has 8 electrons right now around it. 8 divided by 2 is what?
4.
That's where I got that 4 from. Each line means 1 electron when it comes to formal charges. If I looked at the periodic table, I looked at here, how many electrons did it bring? 4. So it brought 4, it has 4. You see how that canceled out? So right now, carbon's charge is a 0. That's our goal.
Tom.
We want the...
Hi, Jamaria.
Hi. Wait,
All
who
right.
said that?
Sabrina.
Oh, yeah. Oh, hi. I just looked. Sorry, Dr. Tom. You can keep going.
Carbon brought in 4 electrons. It has 4 around it. So it canceled each other out for a charge of 0. This is what formal charges are all about. Now if I look at the sulfur, how many lone pairs does it, how many electrons from lone pairs does it have? Look at the green.
4.
There's 4 electrons here. How many lines does it have going to it?
2.
So how many electrons does it have total around sulfur?
No, that's 8.
No, you're right.
Wait.
This is
Okay, but
the
2.
line. When we do formal charges, we're looking at the lines.
Okay, sorry.
Sarita, are you okay?
Yeah.
All right. So if I look at the periodic table, how many electrons does sulfur bring in?
6.
6. Okay, I love your enthusiasm. Okay, it brought in 6. It has 6. So does it have a charge?
It's an electron, so it's a negative charge, right?
But it brought in 6 and it still has 6. So is there any kind
Oh.
of unevenness? I'm looking at formal charges here.
Oh. So it'd just be neutral.
It would be the formal charge is 0.
Okay.
Question is, how do I know it's going to be a double bond here? I have to look at the formal charges as well as the octet rule. That was exhausting, was it not?
Yeah, and I just got here and I want to leave.
Come on, guys. We only have one more week of this. We can do this.
Dude, Dr. Tomery, let me tell you how my week went, right?
Okay,
So
let me pause it before you tell me.
I'm just kidding. There are people on here. It's confidential. Oh wait, there's just 3 of us, and Christian already eavesdrops on everything too.
Oh. Don't we want to get this over with?
Wait, did you pause it yet?
Come on, bro.
So
I'm trying to get out.
Sorry to shut up. You invited me here.
I told you to come, so you know we're going over the homework.
Homework.
Lewis structures and that 4-page sheet that she gave us. 5 pages.
5 pages, Dr. Tomery. What is this? I don't know what you're talking about. 5 pages.
It was assigned Monday or yesterday. All right, so I'm going to continue, ladies, and we can gossip afterwards, so that way the people who don't want to hear the gossip can just go on with their lives, okay?
Oh yeah, I'm gonna watch it.
Okay, you were unpaused, I think. Are you recording again? Yes, you're recording again. All right, so how many things are coming off of carbon here?
4. Oh, yeah, 4.
We have 4 lines, but 2 of the lines are going to the same thing. So that's why I said how many things are coming off of it. So if I'm looking at here, I'm going to rewrite this. You guys can still see my screen, right?
Yeah.
All right. So we have a hydrogen, and a sulfur. Both of these lines are going to the exact same thing. So which of these, so do I have any lone pairs here at all?
No.
Oh.
I don't have any lone pairs on the carbon. It's always the central atom that I'm going to be looking at. I know there's lone pairs on sulfur, but I'm going to ignore those. I'm going to pay attention to the central atom. Okay, so I have 3 things coming off of it and no lone pairs. Structure has 3
Trigonal
things.
planar.
Trigonal planar is correct. So when I come back over here, I'm going to write trigonal planar.
Why isn't it trigonal?
Some people pronounce it that way, but I do not. I think it sounds weird.
Wait, why is it trigonal planar?
Why is it trigonal planar?
Yeah.
Okay, because both of those lines here, this lone, the double bond here, go to the exact same atom. And so there's 3 things coming off of it. Even though there's technically 4 lines, 2 of them are going to the same thing.
So when there's like a double bond like that, you only count one of the lines, and then the other line's considered a lone pair?
It's not considered a lone pair, it's just considered nothing.
Oh, okay.
It's a really thick line.
Uh-oh.
Yes.
Sorry, not you. Muting you.
Okay. All right, that's a shame. Okay, carbonate. I didn't tell you what carbonate was.
Is it CO3 -2?
It sure is. CO3 with a -2 charge. All right. So this is going to be another one of those that you have to actually check for the formal charge, because there will be a double bond involved here. So I'm going to give you a second to pause it and let you think about it first, okay?
Wait, okay, so for this one, you don't multiply it, right? You just you add the extra at the end.
Correct. I add 2 more electrons at the very end. Is that what you mean?
All right, got it.
Okay, I have you guys pause so that way you can actually take some time to think and try to write it out on your own.
So you don't add the electrons in until after you draw it, or you add that in when you're adding them up?
I add them in when I'm adding them up.
Because if you do that, you'll have a full octet for them, except the carbon.
So is it 24 electrons?
6 times 3 is 18. Yes, it's 24 electrons.
Hello?
Yes, we hear you, Jamaria.
No, sorry, everyone just went away. Are we paused?
Yeah, we're trying to figure out how to.
Wow.
Shut up, Christian. What happened?
We're working on Carbonate, and I've paused it so people can think their way through it without being recorded.
Oh, okay. Get back here.
Did you figure out what we were actually doing, Jamaria?
Give me a second. My dog's trying to eat something.
Oh my
Mr. Tom?
I'm so glad she joined in.
So you started. What the heck?
Brenda, did you say something, honey?
Is this gonna be like the top one where you have to add a double line in it or no?
Yes, one of them will be a coordinate covalent bond.
Does it matter which one it is?
Yeah. Because we talked about resonance a couple weeks ago, and that goes into that too.
So
Yeah, I know. Oh, sorry.
I'm gonna take
I'm
one
not so
away.
worried about resonance. I'm just worried about whether or not you can get the basic structure. What, Jamaria?
I know what you guys are doing, sort of. I mean, I know the first two, but the second one. Oh, wait, yeah, I know what this is. Didn't we do this last year? Or is this? Okay, yeah, I remember. You have great memory, like an elephant.
All right. So should we go ahead and keep going now, or are you guys still working on it?
Well, I have a question. Does this one have to be a double bond?
This one will have a double bond in it
Oh, okay.
to satisfy that octet. Sabrina, how are you doing, sweetie?
I have 3 oxygens around the carbon, and then 2 of them are full octets, and then I have a double line, I think.
Awesome. Okay, I'm gonna resume it. All right.
Okay.
All right. So how many electrons are coming off of the carbon? How many is carbon bringing in?
4.
How about oxygen?
18.
It's
Oh,
6
my bad.
times 3 is 18. So you guys are both right. All right. 4 plus 18 is what?
22.
And then because of this 2 electrons up here, this -2, we're going to add 2 more electrons to give us a total of 24, right?
Mm-hmm.
Yes.
All right. So which is going to go in the middle, the oxygen or the carbon?
Carbon.
Carbon.
Awesome. So I'm going to put oxygens all the way around it, and then I'm going to draw the bonds. How many electrons do I have there right now?
6.
6.
So 24 minus 6 is?
18.
18.
So we're going to put the 18 electrons. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. All right, so there's my 18 electrons. Next thing I want to do is double check my octet. Are the oxygens an octet?
Yeah.
Yeah. Is carbon an octet?
No.
No. So that means I can take some of these electrons here and I can make a coordinate covalent bond.
Wait, how do you know if it's an octet or not?
If it has 80 electrons around it. So right now, carbon
Oh,
has
sorry.
4, 6. It doesn't have 8 yet.
Okay, thank you.
Okay, so I'm redrawing this. Out of curiosity, where am I? It's supposed to be a -2 charge, right? So
Yeah.
I should have 2 -1s. Which two atoms hold my -1 charges? Which two have a formal charge of -1? Think about how many electrons are around it right now, and how many it brought into the system.
We added 2, right?
I did not mean to send that, Dr. Tom.
Okay.
Where's the screen?
My screen, I'm rewriting. Can you see that?
Yeah.
Okay. I'm just rewriting it so it's a little bit bigger. How many electrons did the oxygen bring in?
18.
Individually. Each oxygen brought in what?
4.
Not 4, that's carbon.
6.
6. Oxygen brought 6. Now, let's take a look at here. You get 1 electron for each line, and then each side is an electron. So how many electrons are on oxygen right now? I circled.
6.
6. 1, 2, 3, 4, 5, 6. Those are my 6 electrons. What if I did the same thing over here? 2, 4, 6. How many does that one have on the left?
8.
Remember, when you do formal charges, we cut that bond in half. So it's 7. So around that oxygen on the left-hand side, it has 7 around it, but it only brought in 6. So what's the charge of that oxygen?
Negative.
It has 1 additional electron. So it's a -4.
Positive. Oh, wait. Oh, sorry. Stop listening to me.
Negative is correct.
Oh, okay.
So you have a minus and a minus. This is our 2 negative charges. This is a -1 and -2. That's why carbonate has a -2 charge. Because it has those 2 -1s on oxygens. All right. So I diverted a little. I digressed. All right. So we're looking at the carbon itself. How many things are coming off of carbon?
4.
That line's total. How many atoms?
Oh. 3.
3 atoms total. Do I have any lone pairs on carbon?
No.
No. It would look like this. No
Isn't
lone
it the
pairs
same
on
thing?
carbon, and there's 3 atoms.
Trigonal planar.
Trigonal planar is correct.
Trigonal.
Nobody ever says that. I've actually heard several people call it that, and I'm like, no, don't call it that. It sounds weird. All right. All right, so how did that one feel? Was that getting a little bit easier?
Yeah.
Basically, all you had to do is figure out the Lewis structure. Once you figure out the Lewis structure, you take how many atoms it's bonded to and the number of electrons, or number of lone pairs, and then you line it up. In fact, when you're looking at this chart, you could actually, instead of saying bonding pairs, you could probably say atoms connected or something. It's really how many things are coming off of it and the lone pairs. Okay? You guys want to try another one, or do you want to do it on your own? Why don't you try doing it on your own, and then we'll come back together. So you guys start. CH2F2.
I'm taking the porta potty. I'm taking the porta potty.
What in the world is going on over there?
Okay, next circle.
Yeah, some people's email addresses are just ridiculous.
Whose emails are we making fun of?
Somebody's email was KJ Unstoppable. Like, seriously, dude? You think you're unstoppable and you're like 15.
There's no double bond in this, is there?
Nope, no double
No,
bonds in this one. This one should actually be easier.
Well, I'm okay. Yeah.
I got 20 electrons. Is that what y'all got?
Mhm.
Yup. No.
You guys staying ahead of me? Because I kind of just started working on it.
I finished.
Okay, did you guys get this far?
I can't see anything.
There's nothing on your screen.
There's nothing on my screen? What?
There's no right. H2FC.
Alright, let me. Once in a while, I like lose the connection or something. Can you see it now?
Yeah.
I can see it. That's what I got.
Is this what you guys got?
Yeah.
Yay, this is what we got. Okay. So, basically, we have carbon in the middle. Each carbon has 4 electrons. Hydrogen has 1 each, which gave us 2. Fluorine has 7 each, which gave us 14. Altogether, we had 20. Carbon goes in the middle because it's the least electronegative of the 3. Then we have hydrogen, hydrogen, fluorine, fluorine around it. There's no double bonds here because carbon already had a full octet before once we got all the things arranged. Okay, so let's look at our chart.
It's that.
Where does this fit on our chart? We have 4 things coming off of it and no lone pairs. What do y'all think? Tetrahedral is correct. So for the VESPR, we're going to say tetrahedral. So I'm going to stop it from here. All right. Sabrina, you're the one who requested this. Does it feel better now?
Yeah.
Yeah? Awesome. Sarita, you have been sending me emails for like the last couple of weeks. I don't know if you've actually watched the videos or not.
I did watch the videos.
It was a question. It wasn't an accusation.
Well, I just watched them recently.
Okay.
I didn't watch them when you posted them the first time. I just watched them this week.
I just wanted to make sure you weren't confused anymore. That's where that question was coming from.
Dr. Tom, is nitric ion NO3 negative?
Is what?
Nitric ion.
Nitrate? Nitrate is a -1. Why does it say I'm still recording? Stop recording.